Hello friends, welcome back to my class. In today's class, we shall discuss about types of loading. Okay, if you could see here, there are five different types of loadings. Of the first one, this one is called as concentrated loading. This is called concentrated loading. This is called concentrated loading. If at all you see in this diagram, you will see a point load, or the load is acting at a specific point to a small distance A. If this is my load P, it is acting to a small distance A. So this is called concentrated loading. Next, this is my first model. In the second model, this is called as UDL. It means that uniform distributed loading. It means that if you could see these, it means that the load is distributed uniformly throughout the sections, or this load is distributed uniformly to a certain sections. Okay, now if you see this problem, this UDL is acting to a distance of 4 meter of the total beam. Okay, now, and the intensity of this UDL is 20 kilonewton per meter. Then the total load acting by this UDL will be 20 kilonewton into 4, because if at all you see here, it's 20 kilonewton per meter. Okay, now, and here we have 4 meter, so total will be 20 into 4, that is 80 kilonewton of load. Okay, and this load will be acting at the center of this 4. If the total length of this beam is 4 meter, then it will be acting at half, 8 into half. Okay, now, so that is called UDL. Just have a look over it. Okay, and this will be acting at half, means what? 80 kilonewton of load will be acting at 2 meter, means the total load will be acting at half at this point. Then this UDL will be converted into a point load. That is about UDL. See, this UDL can also be represented in this form. If you could see here, the load is concentrated, means what? The load is uniformly distributed through a distance of 4 meter. Again, if you could see here, it says 20 kilonewton per meter, and here we have 4 meter. So the value of the total weight will be 20 into 4, that is 80 kilonewton. Okay, and it will be acting at half of this distance, that is 4 by 2, means 2 meter. So this total UDL will be converted into a point load and will be acting at a distance of 2 meter. At a distance of 2 meter. Similarly, here this will be acting at a distance of 2 meter. That is my UDL. Okay, and the last one is called as UVL, uniform varying load. Uniform varying load. See, this load is varying uniformly. See, the intensity of load is varying. Okay, now, and this is varying to a distance of this one. Okay, now, if at all I write it as some value, if at all I give it as some value, let it say I'll give it as 20 kilonewton per meter. Then the intensity of load, this intensity of load will be nothing but the area of triangle. So this point, what is the formula of area of triangle? That is half into base into height. That implies half base. What is base? From here to here, it's 3 meter. So 3, I want this height. Height is the intensity given. Height is nothing but the intensity of it given. That is 20. So 2 ones, 2 tens. So the intensity of this UVL or uniform varying load will be 30 kilonewton. Now the question is, now where will it act? If I at all see here, it acts half of this distance, but here it acts at 1/3 from point D. From D means from here it will be acting at 1/3. Okay, or else it will be acting at 2/3 from point C. Okay, that is about uniform varying load. Last one is called moment. So this value of this moment will be given initially. Now why should we find this moment? Why is this important? This is important because now in the future class, when I'll be dealing with analysis of beams, you should be able to find some reactions. If this is my A, this is my B point, then here I'll get RA and this will be my RB. So while finding the reactions RA and RB or VA or VB, this moment will be very important. And in the previous class, I told you what are the equation of equilibrium. In that, the third one was moment, equation of moment or moment equation. So this moment equation is also a part of equilibrium equation. So please remember these types of loading, and in the upcoming classes I shall discuss about the analysis of beams. If at all you have any doubt, you can comment me, and please don't forget to subscribe my channel. It's a humble request to subscribe. Thank you and stay tuned for my next video.